Hello everyone. Welcome to the course, Practical Introduction to Sustainable LLMs, Understanding Applications and Ethics. The brand new course of the program that we have at CEDAR. Before that, I would like to tell you that today is perhaps the best day since October in Ireland in terms of weather, very beautiful weather. I hope you are experiencing the same weather or even more beautiful than that in the area you are and you enjoy the day. But thank you very much for joining the course. Yeah, as you could see in the communications that we had before the course, this is the course we have delivered in this season of Lighthouse projects. So if Yelin, you can go to the next slide, please, then I can provide you with a little bit of introduction of who we are. So I'm sure some of you already know us. You already know us. You know who we are. We are CEDAR Island Center for AI. Actually, CEDAR is funded by IDA and Enterprise Island. The main goal and mission of CEDAR is to support businesses and organizations in Ireland to understand, adapt, and leverage the benefits of value of AI and machine learning in their business and so on and so forth. Companies, organization, people, etc., from different scales actually work with us at CEDAR. We work with big organization. We work with SMEs. We work with startups. We work with entrepreneurs. We work with universities, researchers, and so on and so forth through different kind of activities that we do at CEDAR. One of them is the Lighthouse Projects program, as you can see in the right side of the slide. It is a program we have started from 3 years ago. Before that, it was demonstrator projects, where we used actually to uh, select some topics, develop some technical demonstrators around emerging AI technologies, and share it with industry members of CEDAR and provide them with the technical demonstrators, the codes and the license to be able to replicate it and use it in their business. But then, as I said, since 3 years ago, we have switched that to a new program, which is called Lighthouse Projects Program. Still, the main mission of the program is kind of the same, to provide educational content and support for the businesses to understand emerging technologies. Mostly, the target of Lighthouse Project is uh, companies, organizations, startups, entrepreneurs, whatever, whoever who is in a little bit more mature stage. We have other programs at CEDAR that they can support the same for the earlier stage. So at Lighthouse Project, our primary goals are to educate, innovate, and empower our industry partners by introducing them to emerging AI tools and methodologies, and by providing practical applications that enhance their competitive advantages. To do that, we each year we have a season of Lighthouse Project. We are in the third season. And in each season, we do a lot of different activities. We develop courses. We do a lot of short content, educational content around emerging AI technologies. We do technical demonstrators. Normally, we do a few of them, a couple of them during the course of the project. We do uh, technical discussion panels. We do hackathons. We do one-on-one session with industry members, and so on and so forth. So there are several different ways actually we help with the members. Each season in the beginning, we select the topic with the help of the members themselves. They suggest the topic. We generate some sort of the pools, ask them to vote, and then accordingly, with the consultation of the internal team at CEDAR, we select the topics. For this season, long story short, let's make it shorter. For this season, if you go to the next slide, please, Yelin, we selected the Lighthouse projects. We selected the large language models, industrial applications. Yeah, and this is the course. For this course, this course is kind of the most advanced course of CEDAR we have put together. By that, I mean we have lectures, we have technical demonstrators involved in lectures. We have technical discussion panels, sessions that we invite experts in the field to ask them questions. And finally, at the end of the course, we will have a hackathon, a very beautiful hackathon around large language models. So what we want to do is in different materials of the course, we want to do that. So if you come back to the previous slide, Yelin, please. Yeah, as I said, in this course, different people are involved in lecturing, in technical discussion panel, moderation, and so on and so forth. It would be myself, as you can see on the slide, it would be Dr. Adrian Brain, who is going to teach LLM ethical aspect of LLM, very beautiful. We will have Yelin. Yelin is organizing the course and leading the course actually. She has had the main responsibility of the course. She's going to teach two section of the course, two lectures, one lecture, the first lecture after I finish very soon, and then another lecture in week number 4 or 5. I don't remember exactly. She is going to teach another lecture. We have Tina. Tina has supported us and the course a lot in terms of communication as well as the technical aspect of the course. She is going to teach one section of the course, one lecture, which is about RAG toward the end of the course. And we will have Junke, who is going to teach one of technical demonstrators in the next week, which is the mixture of computer vision and LLM, how these two guys can get together to generate much more mature results. And all of us will be involved in technical discussion panels as well as the hackathon. Okay, so I'll stop here. I'll leave it to Yelin. I know she has prepared a lot of interesting materials for this section, and then Yelin can start lecturing this session for us. You have chat Q&A session. Please put your questions there. You can raise your hand, please, whenever you want to ask anything. You don't need to be formal. You can pause us and ask the question. And we would like to hear your voice and your questions, etc., along the way, which will help us to deliver a much better course. And yeah, and again, one more time, very, very happy to have you guys in the course, and would like to see you along the way, and feel free to reach out and engage with us. Thank you very much. Yelin?
Yeah, thank you, Arisa. Yeah, let's begin today's course. And hi everyone. Welcome to the first session of our course, the practical introduction to the sustainable large language models to understanding and the application and the ethicals. So this course is structured as a 10 weeks intensive program, combine the theoretical understanding with practical implementation. Yeah. Here we will have the lecture, have the hands-on labs, and the discussion panel and hackathons. So so today our focus is on setting the foundation for everyone to come. By the end of this session, you could have like the strong understanding of the what's the generative AI and why it matter, and have such clear picture of the large language model, the architecture and how they work, and the key milestones, and also you will learn and have the awareness of the like current trend and future direction in large language models. And all the materials and the stuff, I will show you the information first in the chat, and you can have a look. Yeah, here is like please join the community where we will share the course recording slide and the study materials after the session, and share all the resources here. And here is a lot of links you can get more understanding of us. Yeah. Okay. Okay, let's start. Yeah, here is with the overview in mind of this today's session. Let's dive into our first major topic. What is the generative AI and why it is so significant today? So let me start with something familiar. Yeah, these are some real-world applications that you are already using in your daily life. I'm sure many of you are familiar with the like ChatGPT, the Gemini, and the Llama. So these are examples of the generative AI models in action. So these AI models are all examples of the generative AI application, whether you are using them to generative the text, summarize the articles, create images, or even compose the music. Yeah. So generative AI is powering this experience. So what exactly is the generative AI? So it's refer the AI models that can generate the new content, whether it's be the text, the images, music, and video or code. So by learning patterns from vast amount of existing data. So these models not just repeat the information, they generate the entire new content that mimics the human creativity and understanding. Yeah, so to better understand the generative AI, we need to different between two types of the AI model. One is the discriminative model and the generative model. So for the discriminative model, this model as the traditional model is like classify the data into different categories. Like they could answer the question like if the email is spam or not, if this is a cat or dog, yeah, that is classified. So like the machine learning would be the logistic regression, the decision trees, and the support vector machine. That is the example. But for the generative model, so they can generate the new data that's reasonable, the training data. Instead of just classifying, they create the new output, like show on these images. So if you want the cat or dog, they will generate different category images for the dog or cat. It's not just the classification. So if you ask me now why generative model are required, I can give you 1,000 reasons of the generative model requirement, but here I list down some of them. So the first things you can consider is understanding the complex the pattern from the data, because nowadays you can see people are using the unstructured data a lot of. Yeah, unstructured data means can be the text, can be the audio, can be the video. Yeah, so this is called the unstructured data. So that is why it's very hard to understand the pattern from this kind of unstructured data with the traditional machine learning. So that is why the generative model comes into picture, so this can easily understand the complex pattern. So, and the second thing you can consider the content generation. That means your generative model can generate any kind of content. Everything is possible. Because nowadays, with the help of the generative model, so that is why content generation is the one of most important. Let's say the feature inside the generative model. So the third thing you can consider is build the powerful application. As already told you, we already using tons of powerful application in our daily life, like the chat GPT, the chatbot. Just to try to think nowadays we are having this kind of powerful application. You can do any kind of work actually in a few seconds. That is possible, yeah. So it's also the fourth things, automation and the efficiency. So the business can also using the GEM model for marketing, chatbot, like the customer support and automating the repetitive tasks. So yeah, now that we understand the core concept of the generative AI, let's see how it connects with other AI field. Thinks of the generative AI as the AI artist. This can create new content like song, image, and story based on the pattern this has learned. Now the natural language processing, the NLP, is a field of AI that's help computer understand and interact in human language. It enable machine to comprehend text, the speech, and even the emotion behind the word. So, and then finally, we have the large language model. So the large language model are powerful AI tools within the NLP and the generative AI designed to generate human-like text response based on the deep learning technology. Here is the image will provide a clear visual breakdown of how these area overlap and related to each other. Okay. So the large language model is didn't appear overnight. So they evolve through several stages of the AI and NLP. So we can classify the development into 4 major stages. So at the beginning, the the early days of AI, the NLP will rule-based, simple rule-based system, and dictionaries helps computer recognize the basic word and the structure. So this model has had the limit contextual understanding and will primarily using for the keyword-based search. And then go to the language model stage as the data grow. The AI researchers start using the probabilistic models. This model could predict the next word in a sequence that's based on the past word, but they lack deep understanding. So next, we will go to the neural language model stage. The introduction of the deep learning lead to the major breakthrough. This allowed the AI model to understand the content rather than just the word frequency. And now we are in the large language model stage. The biggest lab come with the transformer-based model. The transformer enabled AI to process vast amount of text efficiently while maintaining deep contextual understanding. So now we have seen the revolution of the large model. So the large model defines advanced generative AI models that specialize in processing and generating human-like text. They are trained on massive datasets, allowing them to learn the patterns of the human language. The key architecture is based on transformer, which enable them to analyze and generate high contextual text. So the large language model don't just memory the text; they understand the relationship between the word, the sentence. Yeah, and you can see, large language model are already transforming multiple industries, like in like the writing and the content creation. Large language model can generate articles, marketing, copy, and blog post. Like for the coding development, the developers can using large language model to generate the debug and optimize the code. And for the developer tools, so like you can see the AI powered tools can help to automate the repetitive coding task like the auto documentation and AI assistant debugging. Yeah. So for the chatbot, we all very know that. So the chatbot could enhance the customer service, the education, and also even the personal assistance. And also for the business operation, large language model streamline business processing like data analyze, report generation, and the decision support. Yeah, like AI can summarize the financial report or generate the automated the email response. Okay, you could have a look. And as you can see, the large language model are not just the futurist tools. They are already shaping the way we work, communicate, and even automated tasks. So let's take a deeper look at the internal architecture, how they actually work at the technical level. So to understand the architecture of large language model, we need to explore the groundbreaking work that made them possible. That is, in 2017, a research team from Google introduced a paper, Attention is All You Need, which is fundamentally change how we approach the NLP. So before this paper, like the RNN and the long short-term memory model, the machine learning model are widely used for NLP tasks. However, this model have some limitation. They process text sequentially, making they slow and computationally expensive. So they structure with long-range dependence, meaning they often lost the contents in long sentence. So the research team proposed a new architecture called the transformer, which eliminate the issues by introduce the self-attention mechanism. This is the key innovation that allowed models to process word in parallel while while capturing the content relationship efficiently. So let's introduce the self-attention. That is the core of the transformer. So it's enabled the model to determine which words in a sentence are most relevant to each other when generate or analyze the text. So here is the example, like the sentence is the animal didn't cross the street because it was too tired. If human, if like me, if like you read this, we can instantly recognize that this is referred to the animal. But however, the traditional NLP model struggling in such a relationship, they often making the incorrect association. But the self-attention solve this by assigning different level of importance. Let's say the weight to the each word related to every other word in a sentence. They calculate the weight. So how it works? So every word in a sentence gets a attention score based on how much is related to other words. Yeah, and if you can see, it is the related to the most important score. So this score help the model focusing on meaningful words while reducing the importance of less related one. So this allowed the large model to perceive content over long passages of text without losing the important information. So the transformer, we can jump to after we know the self-attention, we can jump to the transformer structure. So the transformer consistent two main components. One is the encoder layer, one is the decoder layer. So the encode layer that can process and understand the input text, and decode layer is like generates the output text based on encoded information. So the encode is responsible for analyze input text and convert it into the meaningful numbers representation. Yeah. So the key steps for the encoder, firstly is like here you can see is tokenization and embedding. So the input text will be split into small units called tokens. So each token is converted into a vector. Vector is a list of members. So using the word embeddings. And next, it should go to the positional encoding. So unlike the traditional neural network, so transformers don't process the text sequentially. They need a way to recognize word order. So the positional encoding adding the number value to each word representation. So this will help the model to understand where each word appears in the sentence. And next is the self-attention mechanism, like we discussed. The model compute attention score to determine which word in a sentence are most important for understanding the content. So each word gets assigned a weight based on how much is related to other word. And then we'll go to the feed-forward neural network. The attention scores are passed through a fully connected neural network, refining the representation before sending it to the next layer, to the decoder layer. So the whole encoder stack consists of multiple layers of the self-attention, the feed-forward network, like they progressively refining the word representation before passing it into the decoder. And then we can jump to the decoder. The decoder is generating the output text. Yeah. So the first first steps is the same is like embedding and positional encoding, and then we are going to the masked self-attention. It's unlike the encoder. The decoder only attention to words that's already been generated, ensure that prediction follow naturally. For example, if generating a sentence word by word, the model shouldn't pick ahead at a future word, like look advance for the future word. Yeah. So the encoding and the decoder attention, the decoder tend to the encoder output, ensure that generated words stay relevant to the input. For example, if you ask the question, the decoder reference decoded text to generate a good answer. Yeah, and the next is we will go to the final linear and software layer. So the processed information is passed through a final layer that's select the most probable next word based on the learned pattern. So this decoder stack also consists of multiple layer like the mask, the self-attention and encoder and decoder and attention and the feed-forward network. So that is ensure they combine is ensure the high quality text generation. Yeah, and here is the is like the resource you can have a look is have a detailed evolution of how the transformer architecture works and how they pass the data, pass the how to calculate in each layer.
Hey, Yelin, sorry to interrupt you, it's Tina.
Yeah.
We have someone who's raising their hand, Alan. Should we give the floor to them now, or should we wait until the end of your presentation?
Let me have a look. Let me have a sorry. Oh,
While you're looking at it, there has been some questions in the chat as well. I answered one of them by Robert, but he was asking whether it is possible to find out, understand sources of data or data sets that LLMs are trained on. And I did answer that, and Michael has answered before that yeah, like most organizations do not publicly disclose detailed lists, not normally.
yes, I understand the source. Yeah, we will share the like a lot of source materials and like I will introduce at the end of the course. That's Sita already generate the like collect the lot of resource and data set for the large language model training and fine tuning. Yeah.
And Alan said that hand raised was accidental, so sorry to interrupt you.
That's okay. Yeah. Thank you for reminding. Yeah, thank you. Not illegal. Yeah. So maybe let's at the end of we can have a detailed answer. Let's continue the course. Yeah. Yeah. There's after we understand the architecture, the transformer, and the self attention. So you must be thinking about how to training the large language model. Yeah. So this is a large language model is powerful, but they also now is like the general purpose. They are training in a massive data sets, obtaining the diverse types of information, but maybe some of them and a lot of our want to specific the AI model that can generate the domain specific response, such as like the legal, the medical or business related answer. So there are two major approach to customize the large language model for specific use case. One is fine tuning, is the process of adapting a pre-trained large language model to perform better in a specific domain by training it on additional data. It's like to training the machine learning model again, so that will provide the highly customized response for domain specific application, and this also can reduce the hallucination, that is the incorrect response. Yeah, by making the a model more knowledgeable in a specific data area. And it will improve the efficiency by embedding domain knowledge into the model. But it also have the cons. That's the fine tuning requires large computational resource and the expensive the GPU and TPUs. And this also needs the high quality data sets, which is little bit difficult to get. Yeah, so the fine tuning is good, but it's not always practical. So instead of modifying the large language model itself, another approach is allowing the model to retrieve information from external sources in real time. So this is called the retrieval augmented generation, the RAG. It's a technology that enhances large models by integrating them with knowledge bases, the vector database or document repositories. So this will allow the large model always up to date, unlike the fine-tuned model that may be trained on old data, so RAG can retrieve the live information. And this requires less computing power, so no need for the expensive retraining. Yeah. So that's also could ensure the factual accuracy by pulling vertified and the real world information instead of relying on the pre-trained knowledge. But the RAG is slower, have slower inferences. So the model takes more time to search and retrieve data before responding. So, and the dependency on external sources, if the data source is unreliable or down, the model won't work as expected. So we can compare them both, and the fine tuning is best when you need a highly specific AI model trained on the niches data. But the RAG is best when you need the real-time and up-to-date information from the external knowledge base. And also you can also hybrid the approach to some of the advanced AI application, combining both fine-tuning first, and while it's also allowing it to retrieve external knowledge when needed. Yeah. So the large language model have rapidly evolved over the past 2 decades. Initially, the NLP models were simple, but with more data, the computational power, and also the advanced architecture. So they have grown into the powerful AI model we see today. So here is the timeline of the key large model advanced. Like we can tracking the growth in parameters, the size, and also the training data, the tokens. Yeah, you can have a look. Like the first is Google. They used the 340 million parameters, and you can see in 2023, the OpenAI, in 2022, the Google even using larger, the 137 billion parameters. Yeah. And the total models have now even surpassed the trillion parameters marks, pushing the AI capabilities further than ever before. Like the GPT-4 is shows unknown parameters, but it's estimate 1.8 trillion parameters to training the model. And even nowadays, the Google Gemini using the 1 trillion parameters like to fine-tune for the real-time multimodal processing. So the current challenge is these massive models require huge computational resources, leading to high cost and the energy consumption. So let's see a case study in like the cost efficient AI training. Like this is the DeepSeek. So what is DeepSeek? DeepSeek is a recent large language model designed to maximize the performance while reducing the cost. Yeah, you can see the DeepSeek. They have 670 1 billion parameters. That's performance competing with the models like GPT-4. And you can also have a look at this table, the parameters, the total parameters, and the training cost. The DeepSeek only have 6 million, fraction of the cost of other large models. So because it's like using a better model architecture to achieve high performance with lower energy use. So despite being trained on a fraction of the cost of model like GPT-4, yeah, the DeepSeek V3 deliver a competitive result across the key AI benchmarks. Yeah. So as the AI model become more powerful, so a critical factor that business and researchers must consider the cost and the performance trade-off. Yeah, like we talk about the problem with the large AI models. This means like higher performance often means higher computational cost, and also the expensive API price, and also the energy intensive training, like raise concerns about the sustainability. So that is why the cost efficient AI model like DeepSeek 3 or V3 have merged to balance the high performance with affordability. So actually that's also show the AI industry is moving towards smarter and cost effective and more sustainable models. Yeah. And also, over the past few years, the trend in AI has been toward bigger and more powerful models. We have seen large language models scale up from a million to trillion of parameters that's requiring massive computational power. So this is when the small language models comes in that offer a more efficient alternative. Yeah. So the SLM are the compact AI model designed to deliver efficient and cost effective the solution while maintain the strong performance on the specific tasks. So they usually like less than 20 billion or 10 billions. Yeah. And they have lower energy consumption and definitely with a faster inference speed. So that's the most important thing is can fine-tuned for domain specific application. So they aim to provide the high performance without require massive compute resources. They can run locally, like on a phone or laptop at the edge or the embedding system, and faster response. And even that is suitable for the data privacy sensitive use cases, like can be because it can be deployed on the premise instead of the cloud service. So if we compare the large language model and the small language model, like large language model can be better when you need deeper reasoning and general knowledge across multiple domains. And if you application requires long form text generation or like the complex problem solving, that's the large language model can help you. And if you want to in the locally and have because a privacy sensitive, that is the small language model can help us. Yes. So the AI development has traditionally been dominated by a large organization with vast computing power and financial. So, however, the open source AI initially are changing the landscape. So that's also can making cutting edge large language model more accessible to research to our developers and also the business. And also our research team in CEDA have created the large language model Explore is a powerful live database that help user to explore the vast landscape of the both open source and the closed source large language model. So you can have a look. That's we are including the open source, closed source, and also the fine-tuning dataset and pre-training datasets, and even also the evaluation benchmark. Yeah, so in here you can compare different AI models based on the size, the cost, the accuracy, and the efficiency. So if you want to have a look, just fill the scan the QR code and fill the form that gets the full access. That this will collect all the open source and the lot of machine learning models you can use. Yeah, and here you can update it with the latest breakthrough of the large language model technologies. This is a live dataset. It can up to date. Even some models comes in. Yeah, and you don't need to manually searching the AI model resource. Yeah, and another is Hugging Face is the hub for the open source AI. Hugging Face is the largest open source AI place to providing the access to thousands of the pre-trained large language model, the AI datasets, the fine-tuning script, the AI community. Yeah, so at CEDA, we also contribute to the open source large language model advancement by providing the AI dataset for the fine tuning, you can have a look the financial and the AI vision. Yeah, that this place is allowed AI researchers and the business to build and fine tune and deploy the AI models without starting from the scratch. Yeah, so we are explored the rapid evolution of the large language model, the impact and the advancement in open source AI. But where is AI heading next, and what's the trend of the AI and the large language model? So as we move forward, the large model is not just about the generating the text, is evolving to become more intelligent, more adaptive, and more responsible. So this also in our future session, we will talk a deeper dive into the key trends of the shaking the large language model, like the multimodal AI. So it could be beyond the text-based intelligence, like currently AI models like GPT-4. They already capability of the handling multiple forms of the input text and the images and even the audio. So this is the multimodal AI. The models can become all all-rounder digital assistants capable of the performing complex the real-world interaction. And also for the agentic AI, the traditional AI model is rely on the human intervention for the improvement. But for the agentic AI, it can learn from its own mistake. It can optimize it optimizes itself based on the user feedback and ultimately improve over time without the constantly retraining. So that is new approach to also to unlock the ability of the large language model to become more automatically. Yeah. And also the sustainable AI, like reducing the carbon footprint of the AI model. So like we talk about the AI training, the consumption is massive amount of the energy. Yeah. So the industry is now shifting toward sustainable AI development by like reducing the size and optimizing the AI structure, the model structure, and also like using the renewable energy for the AI training for the data centers. So yeah, this also we will explore in our future sessions. We will also explore what is the large language model as the age and why we need that, and the ethical AI, and also privacy, security, and the ethical consent of the large language model. So that's we will now we learn the revolution of the large language model, the impact of the open source AI, and the existing trend of the shaping the shaping the future of AI. Yeah. So in the next 9 weeks, we will continue this journey.